Describe the process of manufacture of sulfuric acid by contact process. Well, let's take a look. When you're trying to manufacture sulfuric acid, the first step is you have to have SO2, sulfur dioxide. So first, in case you are starting with a sulfide ore or sulfur, they are first roasted in air. They are burnt in air to get sulfur dioxide. This sulfur dioxide is then in step 2, catalytically oxidized to give you SO3. The first step is sulfur is burnt to give you sulfur dioxide. Second step, this sulfur dioxide is oxidized. Now this oxidation part is a bit difficult. It requires a catalyst to form SO3, and then this SO3 is absorbed in concentrated sulfuric acid, not in water. Let me warn you, it is then absorbed in concentrated sulfuric acid for various reasons which I'll tell you, and then this forms oleum, oleum. H2SO4 gives you H2S2O7. Once you have this H2S2O7 of fuming sulfuric acid, that fuming sulfuric acid is then diluted with water separately to give you sulfuric acid. Wow, that is the process? Yes, my dears, that is the process. Look at this reactor for actual conversion of sulfur and oxygen to sulfuric acid. First, we have molten sulfur is being poured, you can see yellow colored, and air is blown in. Sulfur is burning and you are getting sulfur dioxide. This sulfur dioxide, sulfur it burns, it combines with 2 atoms of oxygen to give you SO2 or sulfur dioxide. This SO2 then gets oxidized to SO3. In which way? Now you have a catalyst. Normally V2O5 vanadium pentoxide catalyst is used. Sometimes people use NO2 also, see that is a catalyst, and you're getting sulfur oxidized to SO3. This SO3, see sulfur, SO2 is coming in, there is a catalyst bed, it gets oxidized to SO3, SO3 being heavier sinks down, and this SO3 is then taken away into an absorber. Oh wow, what is this absorber doing? As SO3 rises, now we are raining sulfuric acid from here, and this sulfuric acid, as it comes down, it keeps on absorbing SO3 gas which is moving up, and when it moves down, at the bottom what you have is oleum, H2S2O7. And this oleum is then diluted with water. You mix water in this, and oleum with water gives you nice, happy sulfuric acid. See. This, my dears, is the process, the classic contact process for generation of H2SO4 from sulfur. Let's take a look at the reactions once again. Sulfur burns to give you SO2. This is automatic, spontaneous. You don't have to motivate anything. You just burn sulfur, you get sulfur dioxide. And you know, this happens in Deepavali also. When you burn crackers, you get some sulfur smell, and that sulfur smell is actually smell of sulfur dioxide. Burning crackers release sulfur dioxide, and this is what you smell normally after bursting crackers. This sulfur dioxide needs a little push, some motivation for getting oxidized to sulfur trioxide. This motivation is provided by a catalyst V2O5 or vanadium pentoxide. Sometimes NO2 gas also can be a catalyst, but that is homogeneous catalyst. V2O5 is a very good heterogeneous catalyst, and well, if you just take some heated V2O5 and you pass this mixture, you get SO2 oxidized to SO3. Fantastic. Now, honestly speaking, SO3 has very, very high affinity towards water. What does this mean? It means that very clearly, if you dissolve SO3 in water, SO3 can dissolve in water very exothermically. It was going to release so much heat that entire mixture will begin to boil. So much so that actually what you get is a mist. What? What is a mist? In cold weather, you might have seen some kind of a fog or a mist when water droplets in air condense and give you a foggy kind of a view, right? So does it become cold? No, this is not cold. SO3 with water, everything is boiling, and suddenly instead of liquid, water passes into colloidal state in air and it becomes mist. And unfortunately, this mist does not contain droplets of water. It contains droplets of water which has absorbed SO3, and that has become now H2SO4. H2SO4 is a very dangerous acid, and this dangerous acid, if it is sitting in bottle, is dangerous enough. But if it becomes mist, that means you cannot bottle it up. It is now up in air. It is going to drift away with air. It is going to spread everywhere. And that becomes very, very dangerous because people may inhale this. It spreads over everywhere. It destroys everything. It's most dangerous, as bad as it gets. So this reaction is never done directly, never. What do people do? People say, SO3, you don't react with water. We will give you more sulfuric acid. Okay, now sulfuric acid is already Papa G of SO3. So SO3 cannot create any problems for sulfuric acid because that itself is very dangerous. Somehow they combine to form H2S2O7, which is oleum. Very comfortably, easily, happily. They love each other. And this oleum also releases heat. In this process of reaction or mixing, they release heat. But since you have no water, you just have sulfuric acid, you have oleum, what you find is that usually this heat is not sufficient to convert the sulfuric acid to any kind of dangerous mist. It stays as it is. So some heat is released, you let it cool down, fine, cool, yes, cool. And then in a separate tank, now you take away this oleum, fuming sulfuric acid, deadly and dangerous. And now slowly you sprinkle small quantities of water so that in a controlled way, this oleum gets diluted and SO3 present within oleum reacts with sulfuric acid with water to give you sulfuric acid. And this is the method by which you actually get your sulfuric acid using contact process. This is the manufacture.